Good morning, you guys. Thanks for joining me. Were you both able to print out the blank circle that popped up, the blank unit circle? Can you let me know in the chat area or give me a green check mark? Okay, if not, let's take a couple seconds right now and print that out. If you weren't able to grab it when it first popped up, at the top of our window, under Window, go to Show File Transfer Library. So Window, Show File Transfer Library, and in there are copies of both items. So if you click on blank unit circle, then it gives you the option to save it. It looks like an old floppy disk. So you'll be able to save that and open it up. Because it's really hard to draw one from scratch and have it look nice. So I would much rather us use a blank one, and we'll just fill it in as we go today. So our main goal for today's session is to understand where the unit circle comes from and to understand how to fill it in properly. And then from there, it's going to make our trig so much easier. So our agenda today is again to look at the unit circle, fill in the blank unit circle, and then here is our essential question. I will put it back up again at the end of the session, so you don't need to copy this down unless you just want to. But our essential question is, why do we use the unit circle? And I will be showing you throughout the session why we use it and how we use it. Hi Sabrina, thanks for joining us. So again, please print out the blank unit circle that popped up when you guys came in the room, and that way we can write right on top of it, and it will make the day go much, much easier. If you missed it when it first popped up, you go to Window, Show File Transfer Library. You click on the item you want to download, which would be the unit circle, and then you click on the Save button, which it looks like an old floppy disk. Okay. So what is a unit circle? A unit circle is a circle with a center origin at 0, 0. We'll label that in a moment. And it has a radius of 1. When something has a radius of 1, it's going to make all of our calculations around the unit circle very easy. And what we're going to use the unit circle for is it makes it very easy for us to look at values for cosine, sine, cosecant, all of those things we're going to be able to solve without a calculator. Also, the reason we use the unit circle is that we can verify that any point is on the unit circle by using the Pythagorean theorem. So if we're able to plug in a coordinate in for x and in for y, when we square them and add them, if it equals 1, then we can say that that point is on the unit circle. So here's my blank unit circle. If you have yours printed in front of you, can you give me a smiley face? I know Stefan had his. Dakota was re-downloading it. Okay, excellent. So let me wait just a couple more seconds for you guys to have this handy, because I know a lot of times in class they're just going to give this to you, but I don't want to just give it to you. I want you guys to be able to see where these numbers come from. So let me pop off the mic for just a minute. Okay, so mine actually, on the picture I'm just noticing right now, for some reason I put this really weird graph through the middle, this XY graph. So we're going to ignore that XY axis. I'm not quite sure why that showed up. It will not be on yours. So yours will be just a nice clean picture. Let me actually see if I can drag mine on here, if it's going to let me do that. Let's see. Nope, it's not going to let me drag mine. So it's okay. We'll make it work. The first thing we're going to do is we're going to start at 0 degrees. So 0 degrees is going to be all the way on the right-hand side. We know that the very middle of our circle is 0, 0. And now we're going to go around our circle and we're going to label some things. So my first quadrant here, if I start all the way at 0, 0, and I go up to this point right here, we know that that would be a 90-degree angle. So let's go ahead and put in a 90-degree right here. If I continue to go around my circle, if here was 0, here's 90, Then another quarter of the way would be another 90 degrees. So that would give us 180, which we know is true because that's half of the circle. Coming down another 90 degrees, so 180 plus 90 would be 270. And then all the way back by 0, if we go all the way around the circle, so we started here, we go all the way around, we would be at 360. Does anybody have a question so far about where my numbers came from? Okay, so next we're going to look at our smaller angles here. What this has done in our unit circle again, it has taken our first quadrant and it's split it into 3 different pieces. This one in the middle is cutting it directly in half. Well, directly in half of 90 would be 45. So we're going to put 45 right there on the line. So this one's a 45. So if I come over here, this one's another 45. So I have to take my 90 and I have to add 45 to it, and that's what's going to go right here. So 90 plus 45 will be 135. So here I have 180, and then again in the middle, that's another 45 degrees. So 180 plus 45 is going to give me 225. Here's 270. So 270 plus 45 is going to give me my next 45 degree angle. So 270 plus 45 is 315. How are we doing? So far so good. Can I get a smiley face if everybody is with me? We're just going around the circle. Okay, what do you guys think this smaller angle would be? Anybody want to take a guess? How many degrees is that going to be up from 0? Perfect, perfect answers. Good job. So this is actually splitting my angle into thirds. So here would be my first third, here would be my second third. So my first third would be 1/3 of 90 would be 30. And then another 30 would be 60. So if I keep going around in that manner, if here's 90, 90 plus another 30 would be 120. 120 plus another 30 would be 150. 180 plus another 30 would be 210. 210 plus another 30 would be 240. I have 270. 270 plus 30 would be 300. And 300 plus 30 would be 330. So we got all of our angles on there. Now it gives us another line. The next line that they gives us is for our radians. Last week we talked quite a bit about radians, and we said that radians is just another unit of measure for degrees. It's going to tell you the angle. So just like we have feet, we have inches, we have miles for distance, for angles we have degrees, and we have this thing called radians. So how are you going to figure out your radians? Last week we learned a formula to convert between the two. So let's start here at 30 degrees. If I have 30 degrees and I want to go to radians, we multiply it times pi over 180. Everybody remember how we worked on that last week? Because we said if I have degrees on top and bottom, the degrees are going to cancel out, leaving me with radians. So this would leave me with pi over 6. Pi over 6. Are we okay how I got that? Multiplied times pi over 180? Whoop. I just want it off my screen. I'm not trying to stretch it. I just want it moved. Okay, so let's try 45. So 45 times pi over 180. That is going to give me 1 over 4. So pi over 4. 60 degrees times pi over 180 is going to give me pi over 3. So are we comfortable with how I'm getting those radian values? Is everybody okay with that? Can you please let me know if you have a question? I'm just taking my degrees and I'm using our formula. Now let me teach you a shortcut. So if you are wanting to create a unit circle, and you're wanting to create it fairly quickly. If we know that 30 degrees is pi over 6, sorry, that 6 looks terribly awful. Let's try that again. There we go. So if I know that 30 degrees is pi over 6, I can actually fill in the rest of my circle from here. Let me show you how. So do we agree that 30 plus 30 gets me to 60? Everybody good with that, right? 30 plus 30 gets me to 60. So I would do the same thing with my radians. Pi over 6 plus pi over 6 gives me 2 pi over 6. Guess what 2 pi over 6 is? Pi over 3. So let's keep adding. I just want to show you how the 30-degree marks work first. So pi over 6 plus pi over 6 is 2 pi over 6. 2 pi over 6 plus another pi over 6 would be 3 pi over 6. So 3 pi over 6. Guess what 3 pi over 6 reduces to? Pi halves, pi over 2. So check out the pattern. Pi over 6, 2 pi over 6, 3 pi over 6. Guess what this next one's going to be? 4 pi over 6. What's my next 30-degree mark going to be? 5 pi over 6. My next 30 degrees is going to be 6 pi over 6. We'll come back and fix some of these in a minute. My next 30 degree would be 7 pi over 6. My next one would be 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. It's a pretty cool pattern. It just goes all the way around your equation. So you can use the formula if you want to transfer, or you could use this little technique that I just taught you. So now the thing that we have to do though as we go around is we have to make sure it's in simplified form. So even though we knew that 90 was 3 pi over 6, that can reduce to pi over 2. 4 pi over 6 can reduce to 2 pi over 3. We just want to make sure that our final answers are reduced. 2 pi over 3. 5 pi over 6 is fine because it's already reduced. 6 pi over 6 could just be pi. 7 pi over 6 is already reduced. 8 pi over 6 is going to become 4 pi over 3. 9 pi over 6 is here at the bottom. If we divide by 3, it would be 3 pi over 2. Um, 10 pi over 6, right here in the fourth quadrant. 10 pi over 6, if we divide by 2, I'd get 5 pi over 3. And 11 pi over 6. That is how they come up with their radians. So again, either you can use our conversion formula, which is fine, multiply all your degrees times pi over 180, or you can simply count around the circle. Pi over 6, 2 pi over 6, 3 pi over 6, so you guys kind of get the idea of what I was doing there. So now we need to do the same thing for pi over 4. So here's pi over 4, so if I add an additional 45 degrees, pi over 4 plus pi over 4 would be 2 pi over 4. Well, 2 pi over 4 is the same as pi over 2. So if this is 2 pi over 4, that means this is going to be 3 pi over 4. That means this one's going to be 4 pi over 4, which makes sense because the 4s will cross out, which means this one's going to be 5 pi over 4. This one will be 6 pi over 4, which reduces to here. And our last one will be 7 pi over 4. Finally, all the way at 360, that is the same as 2 pi, or 8 pi over 4, 2 pi. So remember with the radian portion, you guys have two choices. You can either use your conversion formula, or you can count around the circle like what I just did. Can you give me a green check mark if you understand your two choices for radians? And you may like one way over the other way, and I'm never going to tell you which way to do it. And then the last blank over here, yes, thanks Dakota. Next to 0 degrees, that would just be 0 pi. Okay, so let me pause for a second. Does anybody have a question about anything we have filled in so far? All right, now we get to fill in our numbers. So we said that our central coordinate, sort of like the vertex of our circle, but not really vertex. The center of our circle is 0, 0. So if I'm going to come out 1 unit straight to the right, because remember we're talking a unit circle, so if I start at 0, 0 and I come out 1 unit straight to the right, what coordinate is that going to be? What x, 1 y, if I'm coming straight over to the right? Good job, good answers. So let me change pen colors here so that these stand out a little bit better. So that would be 1, 0. Because on the x-axis, I went to the right 1, but I did not go any distance on my y. Let's leave these for a moment. Let's come and go straight up. If I go straight up to 90 degrees, what's going to be my coordinate here? What comma what? What's my x? What's my y? So from 0, 0, I'm going straight up. So if I go straight up, so on x, I didn't go left, didn't go right, so that would be 0 for my x and positive 1 for my y. There we go. Right, straight up. Now if I go straight to the left, that means that my x is going to be -1 and my y is 0. So I didn't go up, I didn't go down, I just went left 1. And now if I go straight down, to this point right here, I didn't go left, I didn't go right, so my x is 0, but on the y I went -1. Are there any questions about those 4 points? So far so good? Now how do I find my missing coordinates here? How do I find these? Well, what we're going to do is we're going to draw in some triangles here. So I'm going to take my 45-degree triangle and I'm going to drop a line straight down and I'm going to make that 45-degree triangle. So let me pull up a new slide and I'm going to make this triangle just at the 45-degree mark right here. Okay, so this we know is going to be 45 degrees. We know that it's a 90 because I'm dropping my line straight down on the unit circle. So here would be the outside of my unit circle. Sorry, forgive me. Please forgive my horrible drawing. There's the outside of my unit circle. I know it's so bad. When one's 45, we know that the other one's 45. You're exactly right. So this is a 45, 90-degree triangle. What do we know about the hypotenuse? Can anybody type that in for me? This is a unit circle. So we're talking about from the center of the circle to the edge of the circle. Yes, we know that that is a 1. The height's not 1. The radius is 1. Let's come back to my unit circle real fast right here. Notice that from the middle to the outside edge, this would be a 1. This would be a 1. This would be a 1. This would be a 1 because every radius or radii on a unit circle is 1. So if I'm making this triangle right here, let me quickly draw it in a highlighter. If I'm making this triangle right here, Okay, that's the triangle that I've put on the next slide that we're working on right now. So this hypotenuse right here is really what length? It is a 1. So 1, because that is a radius of my circle. So let's come back here to my picture. So here's my horrible picture based on our unit circle, and I know that this side is 1. What I'm trying to find are the coordinates of the point right here. Well, the bottom right here, this is your x value, right? It's your side-to-side value. This right here is your y value. It's your up and down. Are we okay with me calling them that? Because again, our x coordinates side to side, our y coordinates up and down. Everybody good so far? You still with me? Because some books just teach you, they'll make you memorize those numbers, which is fine to memorize the coordinates, but I want you to know where they come from. That's kind of a big thing with me. I want you to know they just don't show up out of thin air. There's a reason how they get those numbers for right here. Okay, so what we're going to do is we're going to use Pythagorean theorem because this is a 90-degree triangle. So we're going to say x squared plus y squared equals 1 squared. I'm not stuck. Believe it or not, I'm not stuck. I know I have 2 variables here, but I really don't. Can anybody tell me what we know about a 45, 45, 90-degree triangle? What does that make x and y? Or what do we know about x and y in a 45, 45, 90-degree triangle? Exactly. Our x is the same as our y. They're exactly the same because this one's across from the 45 and this one's across from the 45. So instead of saying y squared, I'm going to replace it with x squared. So 2x squared equals 1. Divide by 2. X squared equals 1/2. So now how do I get rid of my x squared? I'm going to, do we remember? How do we get rid of an x squared? How do I finish solving? Close. To get rid of an x squared, you have to square root both sides. There we go, yes. So I'm going to put it up here where I'm at. Sorry, I ran out of space. That's the great thing about you guys using paper. You have as much space as you need. So when we square root something, we can square root the top and the bottom separately. So this would give me x equals 1 over the square root of 2. What we learned is that I'm not allowed to have square roots in the denominator. So now we do one last step, which is called rationalizing the denominator, where we multiply top and bottom by the square root that we see in the bottom. So on top, I'm going to get square root 2. On the bottom, root 2 times root 2 is root 4. But what's the square root of 4? So again, on the bottom, I get root 2 times root 2, which is going to be 2 times 2 is 4, root 4. And the square root of root 4 is 2. So my x value for this coordinate is root 2 over 2. But we just said that x and y are equal, so that makes y root 2 over 2. So if you're wondering, where in the world did they get those numbers from on the unit circle? Here's where it comes from. We just had to set up a little Pythagorean theorem. So let's go back to our unit circle and let's add in our x and our y. So at 45, I got root 2 over 2 and root 2 over 2. Here's the best part about the unit circle, is there's all these things on our circle called reference angles, meaning if here's a 45, if I come directly the opposite direction, this would be a reference angle. Let me even draw it in for you so we can see it. This one will be a reference angle. It's the 45 degree on the opposite side. And here's why you only need to know how to find these 3 points, because once I know these two, they transfer over here very nicely. What's the difference about this point? The x value is what? What's the difference between this point? My x value is going to be negative. Yep, right? Because you go left and then you go up. So my y value will be the same, but my x value will be negative. So we're going to add in negative root 2 over 2, and my y is still a positive root 2 over 2. So I'm just comparing this point to this point. Do you think there's another point on my unit circle I could fill in right now? There sure is. If I come straight down, let's find another reference angle. It's this other 45 degree. Okay, so what's different about this point? What do you guys think? If I have to go left and I have to go down, what's going to make that point different? They're both going to be negative. Yep, they're both going to be negative. So I'm going to have negative root 2 over 2 and negative root 2 over 2. Let's do our last reference angle while we're here. Let's do our remaining 45 degree angle. And we're talking about this coordinate right here. So this time it has a positive x, negative y, which makes sense, right? We're talking about our 4 quadrants. Quadrant 1 where everything's positive, quadrant 2 where just x is negative, quadrant 3 where they're both negative, and quadrant 4 where only y is negative. It goes back to our basics of our coordinate circle. So I'm going to have a positive root 2 over 2 and a negative root 2 over 2. So we are so close to being done. You guys are doing